r- write and evaluate numerical expressions. So there are some questions related to numerical expression we are asked to evaluate. Whenever they say evaluate, we need to find the answer. We need to add, subtract, multiply, divide, whatever it is, and find the one single answer. So there are several questions here. I won't be able to answer all of them. I'll answer some of them, and the remaining you guys can try. Okay, so here let's take the first question. We have 8 to the power of 2 plus 10 to the 0.8 plus parenthesis 10.8 minus 1.8 times 3. So as you can see in this question, in this expression, numerical expression, you have addition, subtraction, parenthesis, exponent, times. So what are we gonna do first? So in this case, there is a rule that we follow. Okay, so on the screen on the right hand side, it shows you the rule. The rule, it's called PEMDAS, as you can see here. PEMDAS, where P stands for parenthesis or brackets, exponents, then we have multiplication, division, addition, and subtraction. So in a numerical expression like our question we have here on the left hand side, we have to follow this rule, which means we will see if there are any parentheses. If there are parentheses, then we solve them. Then the second thing, we see if there are exponents, we solve the exponent. Then we see if there is any multiplication or division, we solve them. And then we see if there's any addition or subtraction, we solve them. Now when we come to multiplication or division, we have to see whichever comes first from the left, and we solve that one. If it's a multiplication, we solve the multiplication first before division. If it's a division which is coming first on the left hand side, we will solve the division first before we go to the multiplication. And the same thing for addition and subtraction, whichever comes first from left to right. So if addition is first on the left, we solve addition. If addition is second from the left, we solve whichever is first, which is the subtraction. Okay, so there is this rule that is applied between multiplication and division, and there is this rule applied between addition and subtraction. So here in this question we have exponent and we have parenthesis. So as our rule says, we must solve the parenthesis first, right? So we will go to solve the parenthesis first, which is, we keep 8 to the power of 2 as is. So we can write 8 to the power of 2 plus 10.8 10.8 okay, so we have 10.8 minus 1.8. We write 10.8 minus 1.8 gives us 0. 10 minus 1 is 9. So we get here plus 9 times 3. Now again we will go back and look at the rule of parenthesis, exponent, multiplication, division, addition, subtraction, that is PEMDAS. So we look at the rule of PEMDAS and we see that multiplication, which is this, comes before addition, right? So we will solve that one first. So we get 9 times 3 is 27, and we can write, okay, let me move this to the other side. So I write 8 to the power of 2 plus 9 times 3 is 27. Now 8 to the power of 2 is 8 times 8, correct? So we get 8 times 8 is 64 plus 27. 64 plus 27, 7 plus 4 is 11. You have 1 here and you have 1 here. 6 plus 2 is 8 plus 1, 9. So it's 91. So my answer is 91, which means 8 to the power of 2 plus 10.8 minus 1.8 times 3. When you evaluate it, when you find the answer, when you solve them, you get an answer of 91. Okay, let's look at this example E. Okay, so we have here a parenthesis, an exponent. Now here we have two parentheses. Okay, so this one this one is called the smaller parenthesis, okay, and this is the greater parenthesis. So in a question where we have the smaller and greater parentheses, we solve first the smaller parentheses and then we go and solve the greater parentheses. Okay, so we will actually we have here two parentheses here, right? Two small parentheses. So we can solve both of them at a time, because it won't make a difference if we solve them together or we solve them later on. It will still be the same answer. Okay, so we solve these two first. So 1.5 minus 1.5 minus 0.5. 1.5 minus 0.5 will give us 1. Okay, you can check. You can check here. 1.5 minus 0.5. Okay, whenever you're subtracting two numbers in decimals, make sure the rule is you keep the decimals under the decimals and you write the numbers and you write the other digits on either side of the decimal points. So I keep this decimal under the decimal and then I have the decimal here. 5 minus 5 is 0, 1 minus 0 is 1. So I get here 1 to the power of 2. 1 to the power of 2 plus parentheses, I keep the greater parenthesis as it is. 3 plus 2 is 5 times 2. I close the parenthesis. So we have 1 to the power of 2, which is 1 times 1 is 1, plus 5 times 2 is 10. So your answer here is 11. Okay. Let's look at this one. Okay, 3 plus 1 to the power of 3 minus greater parenthesis, smaller parenthesis, 1 plus 5 times 7. Okay, so again in here we can solve this one and this one together at the same time. Okay, and we get 3 plus 1 is 4 to the power of 3 minus parenthesis, 1 plus 5 is 6 times 7. Now I can either solve this one and then solve this one both. That's fine, because they won't make any difference. So I can solve this together. 4 to the power of 3, it means 4 times 4 times 4. Now 4 times 4 is 16, times 4 is 64. 16 times 4 is 64, minus 7 times 6 is 42. So 4 minus 2 is 2, 6 minus 4 is 2. So my answer is 22. Okay. So now you can pause the screen and you can try to answer this by yourself, and at the end of the video I'll show you the answers for the other questions as well. Okay, and this one as well. Okay, try to pause the video, see how we did the other questions, and answer the remaining questions by yourself. Okay, so we move on to the second question. Which expression gives a value 8? So they have given us three options. We try applying the PEMDAS rule on each of them and see which answer gives us a value of 8. So the first one, 32 divided by 8. 32 divided by 8 is 4. Minus 4. Okay, we did 32 divided by 8 first because it has a parenthesis, and following this rule we solve parenthesis first. Okay, so we have 4 minus 4, that's a 0. So it's not a correct answer, because our answer should be 8. Now we have here 32 divided by 8 minus 4, which is once again 32 divided by 8 is 4, minus 4 is again a 0. So this is not correct. Now we check the other one. Now we have division and parenthesis, right? So the rule says you have to go with the parenthesis first. So 8 minus 4 is 4, and 32 divided by 4 is 8. So a correct answer is this one. Correct? Now let's go to the next question. So we have here insert grouping brackets so that the following expression gives a value 32. So here we have 4 times 1 plus 3 to the power of 2 minus 8. Okay, we have to try all the possibilities, following PEMDAS, not following PEMDAS. Here the main objective will be to get the answer as 32. Okay, so we start the first approach by using PEMDAS and see what do we get. So following the PEMDAS rule, we solve this one first. So 4 times 1 is 4, plus 3 to the power of 2 is 9. 3 times 3, which is 9, minus 8. Now we follow the PEMDAS rule where we have addition and subtraction, okay? But we need to follow whichever comes first from left to right. So we have 4 plus 9 is 13. 13 minus 8, 13 minus 8 is okay, it won't be anyways 32, so we don't need to continue, okay? So this doesn't work. So now we try the other approach, which is let's try solving this one first, okay? So we keep 4 times as is, 1, okay, we put a parenthesis, so we know we are going to solve this one first, plus 3 to the power of 2. Now 3 to the power of 2 is as well coming in parentheses, so we solve the exponent first. 3 to the power of 2 is 3 times 3, which is 9, minus 8, okay? So we have 4 times 10, 9 plus 1 is 10, right? Minus 8. Now we can see if we follow this one first, 4 times 10 is 40, minus 8. 40 minus 8 is 32. So here we got the answer. Now in here, in this part, let's say if we would have solved 10 minus 8 first, okay? So we would have gotten 4 times 10 minus 8 is 2. 4 times 2 is 8, which is incorrect, okay? So we cannot go with that option. Okay, so here we get the answer. So that's how you solve this particular question, whereas in which you try all the possibilities, okay? Let's say if this didn't work, okay, then I would have tried doing 3 to the power of 2 minus 8 first, then whatever answer I get of 3 to the power of 2 minus 8, then I will solve with this one, okay? So this would be my first, this would be my second, then whatever answer I get here, I can try this as with the third, right? So but since I got already my answer as 32 here, so I stopped, okay? Okay, let's go to the next question, next topic. Evaluate algebraic expressions. So in this one, they will give us algebraic expressions. The difference between an algebraic and a numerical expression is that a numerical expression doesn't have letters, doesn't have variables. In an algebraic expression, you will have variables. These letters M, G, okay, these are all variables. They are called as variables. So in this topic, they will give us algebraic expression and they will give us values for the algebraic expression. We are supposed to, or we are expected to substitute the values of the variables in the expression and find the answer, okay? So let's start with this one, okay? 8m divided by g. Now I know my m is 5, I know my m is 5, I know my g is 4, correct? So I will write 8m, by the way, 8m, it means 8 times m, and 8 times m, you can also write it as 8m, you can also write it as 8 parenthesis m, you can also write it as 8 dot m. They all mean 8 times m. Keep this in mind because you will have questions like that quite often in solving the algebraic expression. Okay, so a number and a variable 8m, it means 8 times m, okay? So 8m, m is 5, I write here 5, divide by g is 4. 8 times 5 is 40, divide by 4, the answer is 10. So my answer here is 10, okay? Next, m to the power of 2 minus 5 plus half g. So here I have 5 to the power of 2 minus 5 plus half g. G is 4. Okay, now this one is, this expression is of the type half times 4. So you have here half times 4, which is 4 over 2. 4 times 1 is 4 over 2. 4 over 2, 4 divided by 2 is 2. So here instead of half parenthesis 4, I can write it as 2. So I'll continue. Now I have 5 to the power of 2, which means 5 times 5 is 25. I write here 25 minus 5 plus 2. See, so here applying the PEMDAS rule, there is subtraction that is coming first from left. As we go from left to right, subtraction is coming before addition, so we solve the subtraction first. So 25 minus 5 is 20 plus 2, 20 plus 2 is 22. So my answer is 22. Okay. Okay, the third one, 7g minus 3m. 7g minus 3m. Actually, you can do this by yourself. Just replace the value of g as 4, replace the value of m as 5, and solve it. You will get the answer. It's pretty easy. Let's go to the second part. 5b plus 2a, 5b. Now I know my b is 6 plus 2a is 8. Okay, so 6 times 5 or 5 times 6 is 30 plus 16 gives us 46. Okay, and here a is 8 to the power of 2 minus 10 plus half times b is parenthesis 6. Once again, half parenthesis 6, it means, so half times 6, parenthesis 6 is half times 6. Half times 6 is 1 times 6. You multiply the numerator with the numerator. The denominator here, since it's nothing, it's 1. So 1 times 6 over 2 times 1. 1 times 6 is 6 over 2. 2 times 1 is 2. So 6 over 2, which is 6 divided by 2, is 3. So I'll replace that in my equation, and I have 8 to the power of 2 is 8 times 8, which is 64, minus 10 plus 3. Now again, following the PEMDAS rule, going from left to right, I have 64 minus 10 is 54 plus 3 is 57. Okay. You can solve question 1 and 2 by yourself following the same rule. Again, we have the same kind of questions, so I'll take question 2 and question 1. You can do it by yourself, or I'll do it for you. Okay, so 8 times 8.2 plus x, which is 8.2 plus 3.1 divided by 2. Okay, 8.2 plus 3.1 divided by 2. Now there is an addition and there is a division, correct? So the PEMDAS rule says division comes before addition. So as you can see here, division comes before addition, right? So we solve 3.1 divided by 2. Now let's 3 divide 3.1 divide by 2, correct? 2 times 1 is 2, remainder is 1. Now there's a decimal here, so you put the decimal here and you bring the 1 down, right? So 2 times 5 is 10, 10 is less than 11 and nearest to 11. 11 minus 10 is 1. Now I need to try to bring the remainder 0. Right now my remainder is 1. Okay, so what I'll do is 3.1 is same as 3.10, correct? I can add as many zeros as I want. It doesn't make a difference. So I'll start by adding 1 0. 3.10 is same as 3.1. Now because I added 0, I have the chance to take the 0 down. Now I have here 10. Now 2 times 5 is 10. Remainder is 0. So this answer, I get it as plus 1.55, and 8.2 remains as is. Now 8.2 plus 1.55, let's do it here. 8.2 plus 1.55. As I said, the decimal must be under the decimal. So when you're adding, subtracting two numbers in decimals, you make sure the decimal stays under the decimals, and then on either side of the decimal, on both sides of the decimal, you write the remaining digits. Okay, so since it's an addition, it's a 0 here, since there's nothing, so 5 plus 0 is 5. 2 plus 5 is 7, 1 plus 8 is 9. So my answer is 9.75. Okay. Okay, so the next question is 5 times 3.1, right? 5 times 3.1. When you are multiplying a number with decimal, a number in decimals with another number, what you do is to multiply, you remove the decimal. Okay, so 5 times 1 is 5, 5 times 3 is 15. And most important, boys, when you are multiplying, adding, subtracting, please make sure that you write the digits in the correct place. Okay, and you write it as in the form of like a table. So you have here, see, if I make a straight line, I have here this as ones, this as tens, this as 100. This is extremely important so that when you add, subtract, and you have bigger numbers to calculate, you get the correct answer. You avoid having a silly mistake in your questions while solving them. So 5 times 1 is 5, 5 times 3 is 15. So you get here 155, right? Now it wasn't 31, it was 3.1, which means a decimal and one digit, right? So your answer must have a decimal, sorry, you must have a digit from the right and a decimal next to it. Okay, let's say if it was let's say if it was not 3.1, let's say it was 0.31. Okay, 0.31 times, let's say not 5, let's say 0.5. Okay, 0.31 times 0.5. So you multiply normally without the decimal, which means 31 times 5, and you get 155, correct? Now if you calculate the total number of digits after the decimal in your factors, you have 2 digits here after the decimal and 1 digit here after the decimal, which means you have a total of 3 digits. Your answer must have total of 3 digits after the decimal. So you will have, let's say here 1, 2, 3 digits, and you will write a decimal. Your answer will be 0.155. Okay, so this was just to show you how you place the decimals when you are multiplying numbers with decimals. Okay, so going back to our question, so it was 3.1 times 5, so we get 15.5. Okay, so that's your answer. Now here, question 4, evaluate each expression for the set values given in the table, which means they have given you an algebraic expression here. Every time you have to use one of these values, which is 1, 2, and 3, and substitute the value of C as 1 as the first option in this algebraic expression and find the answer and write it here. Then option 2, question 2, substitute the value of C as 2 again in this expression, find the answer, write it here. Then the third one, again substitute the value of C as 3 over here and find the answer and write it here. So you will have 3 answers in this question. Okay, so we start with C equals 1. So when C is 1, we will have 28 minus C to the power of 3 is 1 to the power of 3 plus 6, right? Now we have 28 minus 1 to the power of 3 is 1 times 1 times 1, which is 1 plus 6. Okay, now you have subtraction and addition. So following the rule, we start from left to right, so which means we'll do 28 minus 1 first. Okay, so 28 minus 1 gives us 27 plus 6. Okay, so 6 plus 7 is 13. I have here 1, I write here 3, 2 plus 1 is 3. So my answer with C equals 1. The first answer is 33. Now I will solve for you when C is 3, and you will solve by yourself when C is 2. Okay, so when C is 3, you will have 28 minus 3 to the power of 3 plus 6, correct? So 3 to the power of 3 is 3 times 3 times 3 3 times 3 is 9. 9 times 3 is 27. So you have here 28 minus 27 plus 6, right? See, 3 times 3 is 9 times 3. 9 times 3 is 27, correct? So 28 minus 27 plus 6. So 28 minus 27, we follow the PEMDAS rule from left to right, subtraction and addition. We do the subtraction first. 28 minus 27 is 1 plus 6 is 7. So your answer here is 7. Okay. Now you, in the same way, you can substitute the value of C as 2 and get the value for the other answer. Okay. Okay, let's move to the next topic, simplify algebraic expressions. So in this topic, we will have algebraic expressions and we will have to simplify them. In order to simplify, what we need to know is if there are any like terms. Like terms. Okay, so like terms are terms that have the same variables, like x, like y, like z, like p, like q. Okay, or they have no variables at all, they are just constant numbers. Okay, let's start with solving some examples and inshallah it will be clear for you. Okay, so 10 plus 5y minus 3 plus 4y. If you look in this question, you will have 5 plus 5y and plus 4y. These are like terms because they have the same variable y. Okay, so because I'm doing this is the first question I'm doing for you, so what I'll do, it's very step by step. Now the positive sign, boys, always remember the positive sign or the sign next to a digit, which means, see, the digit here is 5, the sign on the left side of 5 is positive. So always this sign goes with this 5, this negative sign, it goes with -3, sorry, this negative sign goes with 3 and this positive sign goes with 4. So if you happen to move, you should move with the positive or the negative sign. Okay, one more thing, here you don't see any sign. So when you do not see a sign, it means there is a plus. Okay, just keep this in mind. Okay, so as a first step, I'll write plus 5y plus 4y. I bring them together and I move. 10 has no sign, so it's plus 10 and minus 3. Now I have two kinds of like terms. I have this as one like term and I have this as another like term. Okay, so I can add or subtract, so which means I will have 5y plus 4y. The y I keep it as is and I add 5 plus 4 is 9. And then I have 10 minus 3 plus 10 minus 3. Now here look, there is 10 and there is a positive 10, there is a negative 3. The signs are different. When the signs are different, as a rule, you must subtract, which means plus 10 and minus 3. This negative sign, positive sign, they are different signs. So you must subtract, which means 10 minus 3 is 7. Now you look at both the numbers 10 and 3. Which is the greater number? It's the 10. 10 has what sign? 10 has plus, so you keep plus. Okay, so your answer here will be plus 7. You stop here because you cannot add 9y plus 7 because 9 has a variable y, 7 is a constant, 7 doesn't have any variable, so you cannot add them. In fact, in case the y was not there, if the y wasn't here, then you could have added them, or if there was a y here, then you can add them, then they would have become like term. So right now you just leave it as 9y plus 7 because see, the question wants you to simplify. Okay, it doesn't want you to evaluate, it doesn't want you to find one answer because you don't have the value of y. The maximum you can do is you can just simplify, which we did it here. Okay, now let's look at the third example. In this example, there's something you need to know. X to the power of 2. Keep in mind, this x to the power of 2, this power of 2, this exponent 2 is only for x. It's not for whole 6x. Okay, had it been for 6x, they would have written it as parenthesis 6x to the power of 2. Then you can say it is 6 to the power of 2, which is 6 times 6 is 36, and x to the power of 2 is x to the power of 2. Okay, so keep in mind, when the parenthesis is not there, this parenthesis is not there, then the exponent sign only is for the variable. It's not for the whole group of 6x. Okay, just keep in mind. So I have 6x to the power of 2 plus 8 minus 2x squared plus 4x minus 7 minus x. So I will bring the like terms together. As you can see, this is a like term, 6x to the power of 2 minus 2x to the power of 2. Then you have 4x plus 4x minus x. Then you have plus 8 and minus 7. See, there are 3 pairs of like terms. So I can rearrange them. I will write them together as one group. So I will rewrite it, the whole thing, as 6x to the power of 2. I brought the like terms, I wrote them together. Okay, so this is what we got. Now, there is one more thing you need to know. If you can see here, x has no variable, no number. So when you don't see any number, it means there is a 1. Okay, so minus x, it means minus 1x. Okay, so we will have 6x to the power of 2 minus 4 minus 2x to the power of 2. I will write x to the power of 2 as it is, and I make 6 minus 2 is 4. Now here again I have variable x, so I keep the variable x as it is. Now again I have plus 4 minus 1. The signs are different, right? One has positive, one has negative. When the signs are different, you subtract. So 4 minus 1 is 3, and the greater number between 4 and 1 is 4. 4 is the greater number, and the sign of 4 is plus. That is why we have here, that's why we have here a plus. Okay, the same thing, 8 minus 7. So 8 minus 7, signs are different, so you subtract. 8 minus 7 is 1. Now from 8 and 7, the greater number is 8, the sign of 8 is plus, so you write here a plus. Okay, so your answer is 4x to the power of 2 plus 3x plus 1. Now keep in mind, x to the power of 2 and x, they are not like terms. They do not have the same variable, because here we have x to the power of 2, here we have x. You know, it's just like saying x to the power of 2 and x is same as x to the power of 1, right? We can, x to the power of 2 is not same as x to the power of 1. In case you have doubt, you can say 2 to the power of 2, is it same as 2 to the power of 1? No, because 2 to the power of 2 is 2 times 2, 2 times 2 is 4, and 2 to the power of 1 is 2. Okay, so 4 is not same as 2. The same can be said for 3 to the power of 3, 3 to the power of 2 not equal to 3. 4 to the power of 2 not equals 4. Okay, so in the same way, x to the power of 2 cannot be same as x to the power of 1. Okay, so just keep in mind, this x to the power of 2 is one variable and x is another variable. They are not like terms, they are not similar terms. Okay, so this is your final answer. Okay, now in the same spirit, you can solve questions 4 to 7. Okay, after I complete the video, I'll pause it and I'll give you the answers. So you can check, but you must try to do it by yourself if you would like to learn. So let me solve one last question for you. Here m, as I said, m doesn't have any variable next, m doesn't have any digit next to it, right? So when you don't see a digit, there's a 1. Okay, so I'll write the like terms together. Okay, and this is what I get. Now I can add and subtract. So I have here negative and I have here a positive. Following the PEMDAS rule, I must go from left to right. So 7m minus 1m is 6m plus 3m plus 5. So you get 6m plus 3m is 9m plus 5. Now should I add 9m plus 5? Should I make it as 14m? No, that will be wrong because 9m and 5 are not like terms. 5 is a constant. 5 you call it as constant because it doesn't have any variable next to it. So 5 is constant and 9m is has a variable m next to it, so you cannot add them together. So you must stop here. Okay? That's your final answer. So this way we covered all the three topics. Okay, boys. As I said before, you need to solve these questions by yourself. Okay, this one by yourself, and I will solve and give you the answers here. Okay, pause the video and start answering the missed questions. Okay, so here I'll show you all the questions. I have solved them for you. You can check your answers here. Okay, so the questions in green are the ones that I asked you to solve.
Tell them, share and subscribe. Like, share and
Okay.
subscribe.
So here you have these questions. See the ones in greens? I have solved them for you. Okay. So thus I have solved all the review sheet for you. If you like the video, do not forget to like, share and subscribe.